Properties of logarithm. The product rule of logarithm. If x, y, and b are positive real numbers where b cannot be equal to 1, the following is true. Log of xy to the base b is the same as log of x plus log of y. So you can expand this. If x and y multiply each other, you can expand it as sum of these logs. That is the logarithm of a product is the sum of the logarithm of the factors. We're going to use this quite a bit in our calculations. So let's take a look at this example using this property. So if I have log of 3 times 7, that would be log of 3 plus log of 7 with the same base 4. Has to be matches the same base here. Part B, if I have log of 10 plus log of 3, I can write it as a single logarithm if I want. I'm combining this now into a single log of 10 times 3, which is log of 30. Sometimes it would be convenient to expand them, or sometimes it would be useful to write them as a single logarithm like that. Here we have log of 8k, k is positive, the base is 8. So I'm going to write this as log of 8 plus log of k, same base. We know that log of 8 is 1 because it's matching the base. This exponent is 1. So we can write it as 1 plus log of k. Next one is log of m squared. M squared is like m times m, so I can expand this to log of m plus log of m. So we really have 2 log of m. Quotient rule of logarithm. If x, y, and b are positive real numbers, where b cannot be equal to 1, then the following is true. Log of x over y, the base b, is the same as log of x minus log of y. That is, logarithm of a quotient is the difference between the logarithm of the numerator and the logarithm of the denominator. So if you want to expand this, I would write as log of x minus log of y. If I want to combine them together, sometimes you need to combine this into one single logarithm, you write this as log of x over y. Let's take a look at some examples using this property. If I want to know what log of 9 over 4 with the base 7 is, I want to expand this. That would be log of 9 minus log of 4. And then I'm going to put the same base here. This example here, log of p minus log of q with the same base 3, where p and q are positive. That would be log of p over q. Here we are writing this as a single logarithm. We're combining them together. Here we're expanding them. Next one, log of 3 over 16. If I want to expand this, that would be log of 3 minus log of 16 with the same base 4. So that would be log of 3. Now, log of 16, I can reduce this because I can make the base the same. I can write 16 as 4 squared. So log of 16 to the base 4 is the same as log of 4 squared with the base 4. See, as long as I can make the base of the logarithm and the base of the exponential the same, this whole thing can be reduced to 2 here. Okay, that's why we have minus 2 here. Power rule of logarithm. If x and b are positive real numbers, where b is not equal to 1, and if r is any real number, the following is true. Log of x to the power of r is the same as r times log of b. That is the logarithm of a number to a power of equals the exponential times the logarithm of the number. So basically, all we're saying here is we can move that exponent. If I have log of x to the power of r with the base b, I can take that r and move it right here. That's what we're saying. Or I can put them right there. That would be the same as r log of x with the same base. Let's take a look at some examples. So log of m to the power of 5 is 5 times log of m with the same base b. Log of 5 to the power of 4 is the same as 4 times log of 5 with the same base 3. There's more examples here. Log of 5 to the power of 2, that would be 2 log of 5, same base 3. Log of x to the power of 4 is 4 log of x with the same base a. Log of square root of 8. What's square root of 8? You can write it as an exponential. Remember that square root or nth root of a to the power of m is the same as a to the power of m over n. So radical 8, the exponent here is 1. When we don't write anything here, that means it's the square root. So it would be 8 to the power of 1/2. So this one is 8 to the power of 1/2. So I can move this 1/2 right front of the log, would be 1/2 log of 8 with the same base b. Here would be x to the power of 4 over 7, the m over n, 4 over 7. So move this 4 over 7 right front of the log of x with the base 2. Properties of logarithm: if x, y, and b are positive real numbers, where b is not equal to 1, and x is any real numbers, then the following holds true. So here we have special property. We have log of b to the power of r. If the base of the logarithm, the base of the exponential is the same, we said that is equal to just this exponent, r. And that should make sense because we have b to the power of r is equal to b to the power of r. Or also we have b to the power of a log of r with the same base b, also that would be equal to r. That's the one property that we're going to use where r is greater than 0. Product rule: when I have log of x times y, we can expand it to log of x plus log of y with the same base b. Quotient rule is log of x over y. We're going to subtract this. We're going to expand it as log of x minus log of y with the same base b. Power rule would be log of x to the power of r would be r log of x with the base b.